In this video, I want to show you how to balance reactions. So the point of balancing reactions is because we want the same of every element on both sides of the equation. Because right now, if you look at this first example, we're disobeying the law of conservation of matter. I have one calcium and one calcium, which is fine, but I have two oxygens and only one oxygen on this side, so we're completely obliterating an oxygen. So the law of conservation of matter says that no matter is created or destroyed. So the number of calciums should be equal on both sides, and the number of oxygens should be equal on both sides. So to balance that reaction, we're going to put big numbers in the front called coefficients. So I have two oxygens on the left, only one on the right, so I would put a big number in the front to balance out that reaction. Now I have my two oxygens, but my calciums are messed up now because this 2 distributes into the equation. So I'd have to come over here and put a 2 in front of that calcium to get it to balance. So pause the video and try the next one, and then when you get back, I'll show you how to do it. Okay, so I have 2 nitrogens on the left, so I would need to put a 2 there. And I have 2 hydrogens on the left and now 6 hydrogens on the right. So I'd have to put a 3 there to get it to balance. Okay, so these ones are a little more difficult, so I want to show you a trick. So first, balance polyatomics as one thing. Don't treat them as individual elements. And then once you've done all of that, then we can move on to elements. But there is one more thing I want to mention. Always do oxygen and hydrogen last. Those ones tend to be the most difficult because they tend to be in more than one chemical formula. So just do those last and it'll save yourself a headache. Okay, so in the first one, I have 2 nitrates here and only 1 nitrate here. So I can put a 2 in front of that lithium nitrate to get my 2 nitrates. Now when I did that, I have 2 lithiums now. So on the left side, I need to put a 2 for 2 lithiums, which gives me 2 fluorines, but I have 2 on this side, and then I have 1 calcium and 1 calcium. That went a lot quicker when I can take care of the NO3s as one big giant unit. And again, I can only do that if the nitrate is on both sides of that yield sign. If it's on this side but not on this side anywhere, then I have to do every element individually. So try the next 2, and I'll show you how to do them when you get back. All right, so for this one I have a carbonate, and this one I have a carbonate, so I know CO3 is good. I have 2 sodiums, so I need to put a 2 on the other side, which gives me 2 chlorines, so I need to put a 2 on this side, which gives me 2 potassiums, but I have 2 potassiums, so that one's balanced. Now the bottom one looks really complicated. I have 1 iron and 1 iron, so that's good. 1 phosphate, 1 phosphate, so that's good. 1 sodium, or 1 nitrate, 3 nitrates. I should do my polyatomics first. So I'll put a 3 there, which gives me 3 sodiums, but I have 3, which is good, and everything else is balanced. Nice. Okay, so try these 2. Pause the video, and then when you get back, I'll show you how to do them. These 2 are a little more challenging. You might have to be really careful with those tricks that I was telling you. Okay, so let me zoom out a little bit, and let's go into this. So for the first one, I'm going to do, I can't do sulfate as one thing because I have sulfate on both sides, but this SO2 messes it up because my only source of sulfate or sulfur is in this compound. So I have to do every element individually for this one. So I have 2 sulfurs on the right, so I need to put a 2 there. When I do that, that gives me 2 hydrogens, or 4 hydrogens, so I would have to put a 2 there to get my 4 hydrogens. And copper's okay. Sulfate we know is okay already. And now we've got to worry about my oxygens. So I have 8 on this side, and on this side I have 4, 2, and another 2. So that's 8. So balanced. So now let's try the next one. So for this one, hydroxide's not on both sides, ammonium's not on both sides, but sulfate is. So I know that the sulfates are balanced right now, but all the other elements I have to do individually. So I have 2 nitrogens, so I would need to put a 2 there. I have 1 calcium and 1 calcium, and now I have to do the oxygens and the hydrogens. So let's do oxygens next. So I have 2 oxygens on this side. I'm not counting the sulfate because I already took care of SO4. So I kind of like delete that off in my mind. So I have 2 oxygens on the left. I only have 1 on the right. So I need to put a 2 there. Now let's do the hydrogens. So I have 8 hydrogens plus 2 more here. So that's 2. So that's a total of 10 hydrogens. On this side, I have 4 right there, and I have 6 right there. That's a total of 10. So I'm balanced right there. So that's my answer with that one.